Okay, and the next thing, let's share the slides. And then share again this screen and maximize. All right. So first, subnetting is used to, subnetting is splitting a network into smaller networks, especially when they start running out of that address. They start saying, okay, you can give you one address and then try and split it into smaller networks and use it. But the good thing is that you use a smaller subnets as if you're using the same rules and regulations that apply to them in the IP protocol that are used in the internet. So it works exactly the same. The mask is used mainly by routers to hide away the host address, to work out what's really the network address. Because if you're given one network address, and we all know it, but then when you split it down in smaller subnets, nobody knows, where each subnet is. So the mask is the one that identifies each individual subnet. Remember, when you're moving a packet around the world or around a subnet, you always need to know what network address. You can always try to deliver it to the last network, not to the last machine, until you get to the last network, and that's the only time I say, okay, where is that machine, final machine? So that's the advantage of the mask, is to give you the network address in that message that's going, the packet that's going, what network it's heading to. But to reduce, not to talk so much about it, there are two types of questions generally that you get in an exam anyway regarding subnetting. Either split this network into smaller networks, and it's either they're equal size, which is so simple we don't deal with it anymore. We know, how many smaller subnets, you just keep splitting them in halves and that's it. Or variable size subnets. And in variable size subnets, you always remember as well, we can't just give you any size you want. There always have to be powers of 2. So I can't give you 19, and that's a subnet with 19 addresses. It has to be the next power of 2, which is 32. Yeah, that would be the right. Okay. So we can split a network either in a 4, 2, 4. There's no point of doing the 2, but 4, 8, 16, or 42, or 32, or 40, 64, and 128, and so on. And it can get bigger, now 256, and then it can go to 512 each subnet and 1,024 machines. Now we're going into the next byte, where subnets just get bigger and bigger and bigger. So subnets will get bigger when you go and move into the second byte or third byte. So that's one kind of question. We'll do one of those now briefly. We'll practice one. And the other one is if you're given an IP address and it says just out of this, analyze the subnet. Give us the parameters for the subnets in this subnet based on just getting one IP address anywhere in that subnet, in that big network of smaller networks, one IP address with its mask, and you can actually structure the entire subnets in that network and find out where that IP address is in which subnet. There could be maybe 20 subnets or 32 subnets. But which, this IP address that you were given, which of those subnets? Subnet 1 or 2 or 3 or 4? And also, is it a good IP address or not? So you need to know that there are 2 IP addresses that cannot be allocated to users or hosts. And that's the first and the last IP address of any network. So that's another way of doing it. And the cheat sheets are great at doing it. There are many other ways. I can show you other ways, but I suggest get used to one method that works for you and stick to it. That would be the better technique. There's no point of learning too many and you don't master any of them. The technique we took is pretty good, and it's masters, it allows you to break any network into any structure you want. And we'll do the variable ones, because once you do the variable ones, so let's do an example. But in general, if you are given any address, any network address of any class, and if you want to split it into subnets, you can mess around with the addresses of the host, but don't touch the main part of the network. That's what the outside world knows you with. It's like the extension phones in a company. Outside, they call you with just one number that brings that phone, brings that phone call to your company. The rest of it, how you split into your company into different departments and different extensions, that's pretty much the same as the subnet. So, but the thing about it is that you have the same number. For example, here we have 254, or let's say 256 addresses in total. And they're not going to change. If you split it into two, they're going to be 128 each. So in total, you still have the 256. But remember, with every network extra subnet you have, you're going to lose 2 addresses. But that's a general rule. But in general, and all you need is 1 bit. The first bit then is not available to the addresses. That's the reason why. Because the first bit can be 1 or 0. They use it. If it's 0, it represents this part of the network, or this subnet 0, or the first one, or 1 to represent the other one. So in order to know, if you split your network into 2, it's the first bit in the addresses. If we were using this address, we say, here's a class B network, split it into 2. All you need is that bit to split it, to decide 0 or 1. 0 is this half, 1 is this half. And if you look at the number here, just this bit, let's say this number here, it's all zeros to the maximum 1. If this is a 0, it will go, the maximum number then you can write with this 0, the rest of them are 1, that's 128. If this bit is turned to 1, you can write the maximum number 256. So that bit, because it's 1 or 0, it will indicate to you that the rest of the numbers here you can have from 1 to 128, 1 to 7 in fact, and if you turn this into 1, if you have 1 and these are all zeros, that's number 128. And if this is 1 still, but these are all 1s, then that's 256. So in fact, that's why when they say split a 256 into 2 parts, 0 to 127, if you look at those numbers, any number between 0 and 127, the first bit is 0. And any number from 128 to 256, the first bit is 1. Now, if we're going to split it into 4 networks, then we'll need to take 2 bits to have them 0, 0, the first bit, 0, 1, 1, 0, and 1, 1. Okay, so that's just to give you an idea of how splitting and how the mask is important. Once you say this first bit is going to be part of the mask, you cannot use it as part of the host, then it's turned into 1. Now the mask is going to have lots of 1s, 1 extra 1. So in this case, there's 24 1s, but now it's going to have 25 1s. If you're going to split it into 4, then we're going to have 2 more bits. That's 28. But we have it written in a table, in a tabular format, in a much better way. But when a router wants to find out what's the network mask, it actually adds the address. I don't know where that slide is, but all you have to do is take the address, whatever address. Let's say this address here. This is a host address, a machine address on some network. I say, what network is it on? Well, yeah, you need to take the mask, which is /24, which means 24 ones followed by, this one here is 20. 24 ones followed by 8 zeros. If you write that, and if you write the IP address 192 in binary and add them together, All the ones that have a 0, they'll be zeroized, and you come out with only the network address. So that's the idea, that it's done in binary. If you have any address with its mask, and the mask can be written in binary format, or decimal format, or the classless format, or the slash format. But anytime you want to work out what's the network address, you must convert it into binary, like this. Then you must take the address, convert it into binary, and add them together. Anything added with 0 is going to be turned into a 0. So in this particular example, all these bits will be turned into a 0, and will leave you with the network address. So always, anytime you add a mask with any address, it will give you, you come out with the network address, that where that address belongs. I don't know if it makes much sense, but only with trying it out. Okay, so normally if you have lots of addresses in a network, like this example here, 256 addresses, we know the first one, 0, is used to identify this network, and the last number, 255, is used as a broadcast address. If this is a /24, that means there are 24 ones before it, which is just the last byte. We're going to have 256 addresses in it. So /24 has 256 addresses. In total, 2 of them cannot be used. So we can say 254 host addresses, but the other 2, we call them addresses, but they cannot be given to hosts. Right? But if we split it into the next level, right, that means the mask is going to 1 extra bit. So now we have 25 ones. As you can see, it's /25 network is half the size of /24, or /24 network can be split into 2 equal halves of /25, or we can split it into 4 halves, 4 quarters. So you start with this network, /24. If you split it once, you get 2 networks. Split it again, you get 4 networks. But really, the total number of addresses are pretty much the same. You're not changing the number. You still have a total of 256 addresses. If you split it into 2, they're going to be 128 each. If you split it into 4, they're going to be 64 addresses each, and so on. So just remember, as you go higher with the mask, that means you're going to have smaller networks. And the cheat sheet will show you that. And you can work out. There's a common question. They say, right, how many /27 networks you can have in a /24? Okay, you can go from 24, split it to 2. Let's say go to /25. You split them into each one of them, split into 2. So now you're going to have 4 /26. And, oh, sorry, we start with 24, then 25, 2, 25, 4, 26, and 8, 27, and that one. But sometimes the numbers are a little bit too far and you keep counting, so it's easier to say, right, 27 minus 24, that's 3. 2 to the power of 3, and that gives you the number of them. So if you're asked, well, how many, for example, /27 networks in a /20 network. So /20 is much bigger, even than 24. It's double. 23 is double the 24, and 22 is double 23, and they keep it. So it's fairly big network /20. But it's easy. You can say /27 minus /20, that's 7, 2 to the power of 7, and you work it out, and you find out the size of each network. Well, sometimes you get a quick question in an exam with simple marks, but so it's good to know this. How many networks you can get, how many /27 networks you can get in /20 network. And you should, subtract and use the difference as the power, and use the cheat sheet, and it'll tell you how big each network is or how many networks then you can have. All right, so, and the attributes of a network, or sometimes they call them parameters of a network, but the attribute is the better word. anytime you are asked about subnet, you are expected to automatically give us the ID, the first legal address that can be given to a host, the last legal address, which is broadcast, and the one before it, which is the last host address. And you should also give the mask, which can be given in the CEDAR notation, that's the slash notation, or binary, or decimal. Ideally, you should always provide the decimal because we understand it. Only occasionally you need to provide the binary if you need to end it with the actual address and work out what the network address is. Okay, so we worked out the cheat sheet, and get to know how to create one very quickly. If you ever go for Cisco, it's handy to do it because in Cisco you have no time. Your tests are time limited. So if you can, before the test, work this out on your notes in front of you, it will be handy. So you start with the numbers 124.862.128, and they represent /25, 26, 27. So these are the masks, and that's the size of how many machines are in each network of this size. So earlier we were looking at /27 network, just 32 devices. /24, so even though it's outside this range, double that, that's 256. In fact, /24 should be here, the next number. But okay. So now we are just looking at the last byte, the fourth byte, which is the smallest. And then you work out the actual dot representation of this /25 ones when you put them. And then you're left with, /25, then you're left with 7 zeros. So only the first bit is 1, the rest of them are zeros. That's the number 128. If you're asked to convert it into binary. But the way we do it, we start with that number 128 here, just to do it quickly. Plus 64 gives you 192, plus 32 gives 224 and so on. So, and this is the same as converting. If you have 8 bits of 11111, that's 255 or 256. And then if you remove the first one, it's 255. You put 2 zeros here, that's what the number you get. But this is what we want. 128 is 1 with 7 zeros. That's 128. If it's 1 1 with the rest of them zeros, that's 128 plus 64. That's total of 92. That's the mask. That's how you work it out. That gives you an idea, an overall idea. Once you have the general ideas, you can work it out. This is if normally we work the same bytes, but now remember the 4 bytes. If we have 3 of them, and the last one that's class C, is the one we implement. This is class B, class A network. So see, that's why we say /15. That means you only have 15 ones. It's a huge network. You have, so many zeros in front of it. But if we are talking about, say, the second byte here, there'll be 16 ones before it, and now this is, if we add this, is 17. But in 1 byte, it's the same value. It's like if this was 1, and the rest of them are 0. In the third byte here, it'll be 128. But remember, this one will have another byte that's 0. That's 8 zeros. So the /17, even though it has 128, same as 25, but 25 has 1 to 8, but it's the last byte on the right. This one is the second byte on the right, still have more right. That's when I say, even in our decimal numbers, 100 is different to 1000, because even though the number is 1, but 1 happens on the next column. So same as this one. This is happening on the column before this, so it's like this one is here. You continue /24, /25, /26. Our number here, even though at this byte it's 240, but this is 240 and there's about 8 zeros in front of it. But this one, this might be 240, but that's it. There's only 4 zeros in front of it on this side. Okay, so I don't know if there are examples here. Okay, so let's get into a quick one. Here's an address. This is one typical question. Here's an address check it. Is it, what structure is the subnet, and is it a good address or not? This is a typical exam question as well. So, and this is /28, it says. So out of the cheat sheet that we just created, /28, that means every machine has 16 addresses. Every subnet has 16 addresses. Okay, where do we start? What's the first address? Now you are given this address. This is like 20, this is /28. That means it's based on class C networks, based on the /24. If it's the next address, for example, let me go back again, back to the previous. If you get /20 address, that means it's based on the /16. So that's class B. So if you are given any of these addresses as a subnet, that means your network really, the International Internet Authority will give you an address that's a class C. But inside, you can split it into any other addresses. You can split it into two 128 networks. Let's say they give you class C of 256. You can have any of these within it. You can split it into two, that's /25, or 464s or 832s devices within or addresses in each network. So if you get any one of these, then you are really working on a /24. You get any of these numbers, anything more than 16 or less than 24, up to 24, that means you're working on /B network. So this particular one is a 28. That means we're working on the /24. That means the last digit is 0. That's what the network address is. So in order to work it out, the first network, the normal address, the international authority is giving you through the network provider or the service provider, they give you this address. So you got this address for your company, 10.20.1.0. You're allocated this address. This is an address for a network that contains 256 addresses. 0 is the identifier for the network. This is what the world knows your network by. 10.20.1.0. If you put any number here, the network will say, still, that's a device. Let's say you put number 70 here. The world will think you have machine number 70 in this network. But we're going to split this network into smaller subnets. The world does not know how we split it. And this is another advantage of subnetting. The world doesn't know how you actually split it. Doesn't matter what they see. They see an IP address, but they will not be able to tell if we split into 2 or 16 networks or 20. We will know by looking at the math. So anyway, now, once we know where we're starting, you always starting point, if it's a class C network, the last byte is 0. If it's a class B network, your last 2 bytes are zeros, 2 zeros. And class A, then the last 2 zeros, the last 3 bytes are 0. So this is what a standard class C network is. Now we have that network. From that address, we realized what that network is. In fact, if this machine was not split, if this address was not divided into smaller networks, this would be machine number 50 in the main network. This is the network. But because we split it, we could have split it into 2 networks or 20 networks. Where is that 50 going to fall? So this is what gives us the idea. /28, looking at the cheat sheet, we know that we've split this network into a group of networks that each one of them will have 16 addresses. So we can work it out immediately from here. The first one starts at 0, and the next one you add 16 to it, starts at number 16, that's the second subnet. The next subnet you add 16 to it, 32, 48, 64, and you keep going until you finish the 256. Okay, so that's really the main part. Now, once For each one of these, you can figure out the attributes. That's the identifier for that network. Notice, guys, the first identifier, the first address that identifies the first subnet is exactly the same as the identifier for the entire network. And this is initially when they started networking or subnetting, they had a problem with this. They said, listen, every other network we can identify by this number 16, we know it's the second network. If it's the number, find the number 32, that identifies the third network, fourth network. But if you find a 0, is this identifying the entire network, or is it identifying the first network, the first subnet? Because it's the same. So for starters now, you should know that the first subnet always gets the address of the main network. Okay, that can be a problem to some systems, but it worked out that it's okay. Because normally, if we write this address with /28, then we know it's a subnet address. If it goes to /24, then that's probably the main network. So now, right now, this way. Okay, so each one of these here will have a /28 if they are all /28 networks. Of course, this is dividing it into equal sized networks. So now, once we view, this is divided into a number of networks. We don't know how many networks, but each network has a 16 device. Then we can have the starting address or the identified address of every subnet until, for example, we're looking for number 50, device number 50, which network it will fit in here? It will fit between those two networks. It will fit in this network. This network starts at 64 and bigger. So 50 falls in this, within the scope of this network. We should call this one subnet 1, 2, 3, 4, so we can in your answer say, hey, this address falls in subnet number 4. Now we need to find out, could it be the identifying address or the broadcast address? We find out. That's why you need, that's when you have to expand this into the 5 or 6 parameters we want. So it's identifying 48 identifies the subnet. And the last address, the broadcast address for this one is the one before the next 64. That's the one before it, which is 63. There it is, the broadcast address. Everything between the ID and the broadcast are normal addresses. So you can write them. So any address here to there can be given to any computer, any router, any printer. But those two addresses cannot be given and should not be given to any host or any printer or any router. Okay, how many addresses are in each network? We know 16 is the total number of addresses, but 16 includes the ID and the broadcast. And therefore, the total number of hosts we can have are 14. Okay, and what else? You can then also convert that mask. Obviously, this is like a class C. That means it has /24. That means it has 24 ones. The first 8 ones are 255, converting into binary, into this, into decimal. And then the next 8 ones and the next 8 ones. And the rest of them, this one has /28. That means you can actually get these from the table there, but it just means it has 4 more ones. And if you take any byte and put the 8th bit to 1, the 7th, the 6th, and the 5th, and the rest of them zeros, convert it into decimal, that's what you get, 240. But this table gives you the conversion without you having to calculate. So to write its mask in decimal, there it is. If you want to give us the slash representation, that's like saying /28. This number here with 240 is similar to saying /28. And it's easier actually with /28 if I say convert this to binary. To convert this to binary, okay, you know that 255 is 8 ones, 255 is 8 ones, same here, but 240, some people might have a bit of a problem with. Right, it's 128 for the first one plus 64, and that becomes 240. No, that becomes 192, and then the next two ones, 32 and 16, they bring us to 240. But with this table, you can give you the number immediately. That's easier and more kind of quicker to convert into binary. All right, so imagine now maybe if you can work something out of this. This is just a quick example here. We got another IP address, for example. Let's go here with, instead of 28, imagine if we got 64, /64. What that? If I can just type a number here instead of this. Imagine, work out this example. Can you work out this example, please? 10.20.100 or 150. Sorry, .1.150 /64. Can you work out the parameters? Is this a good address or a bad address? And which subnet it is in? Okay, that's slightly different, but work it along the same basis. You want a piece of paper? No? Anybody wants a piece of paper? No? Well, it might take 2 minutes at it. Don't take any longer than that. Let's go to the next. Okay, good. Let's continue then. Okay, first you write the IP address and work out what's the network address for that. This is based on /24 network. So it's not /26, sorry. So the mask is /26. So this is based on a /24 once it's above 24. You want to find out how many devices is in each subnet from the mask and the cheat table. How many networks are in? How many subnets? How many /26 networks that now we are having? We're talking about /26, and the original is 24. How many networks are in? How many /26 networks are in the /24? 26 minus 24 is 2. Yeah, 4. So they should be 4 networks. That's one way of looking at it. You can work it out. But you can work it out from it. Just where does it start and how big each one is, and you go. Okay, figure out how many.
Yeah, no, I didn't.
We're going 26 and we're starting with 24. So 26 minus 24. That's 2, 2 to the power 2, that's 4 networks. The first one, what's the address of the first subnet in this network? So we're going to have 4 subnets. The first is always just put a 0 in the last byte because it's 24. Okay, I hope this one works. What's that address again?
1021.50.
Slash 26. Okay, so everybody's done it? Everybody's worked it out? All right. Oh, yeah. Oh, I think it just cool down or something. So that's the address. The network address for this one, because this is based on /24, /24, the last byte is not used, so the first subnet, or the first network address is going to be, the main network address is this address here, 1020.1.0, and that is also the same address that we give the first subnet. So the first subnet is going to get the first available address. Of course, if now it's /26 instead of /24. Now, how big is each /26 network? Have you checked it out off the sheet table? And how many addresses are in each one of those /26 networks? 64. So the next one is going to be 0 plus 64. So this is subnet 1. Starts at this point. Subnet 2, you add 64 to it, and that's 64 of what? So it's the same address, but that's, yeah, they all, remember, they all make the same address from 0 to 256. But now it's going to split it into networks. Each one of them will have 64 addresses. So the first one is going to have from 0 to 63. The next one is 64. You add another 64, it becomes 128. That's for subnet number 3. And subnet number 4 is going to be plus, what's that? 196? 192. So these are the first address of each of the 4 subnets we're going to have. How do I know it's 4 subnets? 2 ways I can find out that there are 2 subnets. First, we start with /24, but now we want to make /26. How many /26s we want 24 have? 26 minus 24 is 2. So I put that as a power of 2 and make it is 4. That means we're going to have 4 subnets. That's one way of finding out how many subnets we're going to have. But the other way, you can just keep on going until you reach the maximum, 256 or 255. So it's 0 to 63, 0 plus 64, 128, 192, 192 plus 64 is 256. There's no 256, 256 is the next address, so it's gone past 255. So 255 is the last address in this network. 191 is the last address in this network. And 127 is the broadcast address, or the last address for the first one, and so on. So these are our subnets already forming the parameters. So it's important to know how big each network is. And where do you start? You start at 0 and you keep incrementing the numbers. And every increment is going to be the next network. That's the next network. The next subnet. When you reach, this is subnet 4, it ends at 256. 255, sorry. 256 is another number. There's no such thing as 256. The next address, what's the next address after this? This address, remember, is 10.20.1.255. 1, 2, 5. This is the last number in the original network. 10.20.1.255. Because the original network started at 0, ends up at 255. That's a total of 256 addresses. What's the next sequence in these addresses? Can you figure out? Of course, remember, there's no such thing as 256. It's like when you count our numbers from 0 till 9, there's no 10. There's nothing after 9. So, what's the next number here? What's after 255? This is like in the modulo, when you reach 8, there's no 8. We go back to 0 and increment the next column. Like in our decimal numbers, when you reach 9, after 9 you put a 0 and increment the next number, so you have 1. And then the numbers again start count from 0 till 9. When you reach 19, you go 0 and increment the next column. Same here, in binary. Because each one of these is a byte. The maximum, the largest number you can write in a byte is 255. That's 1, 1, 1, 1, 1. Add one more 1, you can't have 256. So if you go to the next column, add 1 to it, and this goes back to 0. That's the next number. After 1021, 255, the next number is 10.20.2.0. That's the next logical number. But that belongs to another network, so our network stops at this point. If we were working, just if we were working on /B network, not /C, that means that's these two bytes are the network address. And you're counting with this 1, 255, still one number, Yeah. So when this goes to 255, the next one is going to be 2.0 of the same network. We're still on the same network because it's a much bigger network. But because right now we're /24, that means these are already defined and finished. We can't touch them. So whenever we reach to the end of this, that's it. We go to another network. But if we were in a /B network and this one goes 1, 0, 1, 2, 1, 3, well, this goes to 255, this goes 2, and we haven't filled all the addresses of /B network until this one reaches 255, and it can go to 256, or else lead to another number, another network. But let's just stick to /C network. So if you get any IP address of /24, if it was, let's say, I want to complicate it, but let's say, imagine if we got the same address, just for argument, just so you know the idea, 150, same address, but instead of /26, /20. The /20, that means that's based on a /16. This is class B kind of network. So you figure out, and then you find out, in fact, if I can get 26, let's say, not 26, let's see, that will be the equivalent of 18. Let's say /18. This example here. You will come across them, but not this semester, but the idea is the same. Here's where do we start? Let's say we want to see, where is that address? What subnetwork is it on? Well, first, let's say you need to know where is the starting address and then how big each network is, each subnet is. What's the starting address now in this case? Because the address is bigger than 16, and we're now talking about class B network. That means class B network, that means the first 2 bytes are fixed, internationally, and the last 2 bytes are 0, 0. That's our first address of the network. So any device on this machine internationally, they split, they move, they get rid of the host address, that's what they have. 10.2.0.0, that's the network address. Just to deliver a packet that has any address in this network, it's a huge network. When they say mask it off, you mask the host, that's what you get. The network address from an international point of view. But now, we're going to split this network into smaller networks. How big is each network? Can you check in your cheat sheet? How big is the 18/18? 64. How come it's 64 and the last one was also 64? What's the difference between them? Are they the same size? No. When we say /B network is split into 64, we mean in this column goes from 0 to 64. So this, the next network, the next subnet is going to be 10.2.62.0. See, there's a difference now when you're incrementing the second column. How many machines are there? Huge number of machines. 64 times, each one of them goes into 255. It's 255 done multiplied 64 times. That's how big the network is. But we use the same technique, the same idea. It's just instead of incrementing the fourth byte, now we're incrementing the third byte. It's like when you are moving to a different scale of money, and they say to you, listen, we'll give you an increase of, say, one number, but one digit will change. If you're like working in McDonald's or someplace where you're paying £12 an hour or euros an hour, you know that one increase is going to be 13 euros an hour. But if you're working, say, I don't know, you're an artist, and you're working, you get paid by the hundreds, and so we give you one extra number. So instead of 500 paid in your life, we get paid 600. Then that one is different because it's going to be put in a different column, and so on. And if you are kind of, I don't know, whatever, expert in something that you charge per £1,000, today you might charge £6,000 for doing something real, and they say we'll give you an extra one number. That means an extra 1,000. So here's saying here, if you're increasing a number, if you're increasing your network, you're increasing it in the fourth column if it's class C, but if it's class B, we're increasing this column. And the same numbers will work for class B as well, but we'll be talking about this column, which the number is going to be. So this 64 increase is in the second column, which means it's a huge increase. So, all right, so we'll go, and then the next network is going to start at this number, which is 128 here, but a 08. So what's the broadcast for this network? This is subnet number 2. What's the broadcast for the one before? You want to have a guess? No. 255. Because if it was a 0 and you add 1, that's still going to be 127.1. But now 255, you add a 1 to it, it's going to go to 256, which makes this a 0 and increment this by 1, and that brings us to the next network. And that's really the only difference between different classes when we talk. Just we talk about class C because simpler, we can do a lot more work and quicker. But with this one, it's pretty much the same idea, but now we're talking about larger scale, and you just need to know this. Where's the broadcast for this one? It's 255, and that increases it. So all the networks from 64.1, 2, 3, 4, all the way to 255. And then when they get to 256, this becomes 65.1.2.3, and then huge number of devices. But this network is fairly large, and it's going to have very large number of machines, but there it is. We only have 4 major subnets. But of course, most of the time they split this into a lot smaller subnets. Sometimes they split it into 200 subnets, and there's still probably 1,000 in each one of them. But anyway, I just wanted to give you the idea of how to, if the scale is bigger, how does it work? It works pretty much the same. It's just which column are you working on, and when does the number increment. So what's the broadcast address for the first subnet in this one? This is the network address of the next subnet. This is subnet 1, that's subnet 2.
How to broadcast it. So it's 255.0. No, 255.
Okay, it's 10.2.
63.
63.5. Yeah. So when you add 1 to this, it's going to turn into a 0, turn this into 64, and go to the next step. But we don't have to worry about that now. So we'll worry about this. So we've already decided that our network is /26, and we figured out that it's size 264. Every network has 64, so we start with 0, add 64 to it, and we find that after 4 subnets, we stop adding or stop working. We realize it has 4 subnets. You could have realized that by saying, oh, we're starting from 24 to 26. Well, 26 minus 24 is 2 to the front 2 is there are 4 subnets. So if you're asked a good question, how many subnets you can have in this, split the one mask minus the other, the number you get, make it a power of 2, and that will give you the. And that's the idea is simple when you split it, because it's binary. Everything is split into 2, so your numbers are going to increase from 2 to 4 to 8 to 16. So it's a quick way of finding out. And then you work out, that's the identifier, 0 is the identifier, 63 is the broadcast. The first available address is, the first host address can be given here in this subnet is what? 1. 1.1. And the last legal one?
Yes.
63 is its broadcast. 62 is the. And any number between 1 and 62 are legal numbers you can give to hosts. 0 is the identifier, 63 is the broadcast. For next subnet number 3, what's the identifier? This is subnet number 3. Identifier of broadcast. Yeah. Yeah. And the hosts are? The host is 127. 127 is 129 to 190. Okay. There's another question is asked. These 2 addresses are having problem communicating. What's wrong with them? And they give you an address, for example, the 150. I don't know where the 150 is. Do you know where the 150, which network? Pardon? Yeah. Now subnet 3. Somewhere here is the 150. Sometimes you're told 2 numbers, 130 and 150, they cannot communicate. Why? They can't communicate, they're going to do a proper communication, but if they want to broadcast, if 150 broadcasts something, 128 doesn't get it, or 130 doesn't get it. The reason? The idea why? What? Yeah, they're in 2 separate subnets. See, if any machine broadcasts in this network, subnet, broadcasts only these machines on the same network of broadcast. Now they are on a real local area network. Even though, over the scale, we say they're all in the colors, they're all now a local area network, yeah, but they're not in the same subnet. Normally, if you have a local area network, with no routers, you can broadcast, everybody gets that broadcast. But if there's a router and there's another, your network is split into 2 by a router, when one of the machines broadcasts, only one side gets it. The other side doesn't get it. You don't get a broadcast. So if this is the kind of question sometimes you get, they're given 2 IP addresses. That address got 150 and another address got 130. They're having problem communicating. What's wrong? We have to do the same thing. This is really the basic idea. Create the subnets, split them into subnets based on the mask, and find out, are they in the same subnet or not? Sometimes, yeah, maybe they don't tell you it's 130 and 150, because obviously 130 is in this subnet. No, sorry, 120 is in this subnet, and 150 is in that subnet. Because this one, anything between 64 to 127 is in this. So they are in 2 different subnets, and therefore they will not be able to communicate. But they'll be able to communicate through normal communication, but not through a broadcast. Now, the other addresses, they probably tell you, listen, 150 and 192, they cannot communicate. Why? Why is that? So again, if you split, either based on this or on this, you split it, you start at 0, you start incrementing based on the mask that tell you how big it is, and then you search, where is 150 and where is 192? 150 is a proper address in this network. 192 is an identifying or ID address, which is a legal address to give to a host. That shouldn't be there. So sometimes they give you an address that's a broadcast address that shouldn't be given to a host. You ask how they cannot communicate. They cannot communicate because it's an illegal address to be allocated. So this is a very common question. If you get addresses like these, they say, what's wrong? Or, you know, show us the parameters, or what's wrong with the communication. Now, let's have a quick subnet addressing variable size network. Let's say these two routers, and this one has, say, 40 machines. This one has 2 networks. One is, I don't know, 90 machines, and one is 32 machines. Can you work this out in a few minutes? In the last 3 minutes for subnetting? Did I give you the address? The address for this network is, let's say 10.7.3.0. That's the address we have, /24. Can you split this into a number of subnets? How many subnets? First, you need to know how many subnets are there. Can you tell from this diagram how many subnets? And these 2 circles are routers, by the way. I just marked them here as router 1 and router 2. How many subnets in the diagram? Every branch, every interface to a router, that's a subnet network. 1, 2, 3, 4. Yeah. Okay, can you see the 4?
Yeah, so the router is 2.
Yeah. So these are the different networks, the 40, the thing, I call them subnet A, subnet B, subnet C, and this is the link or the interface between the routers. This is a separate network, let's call it separate network D. That's all there is to it, but 4 addresses are needed. Even though recently they said you can, but let's stick to the 4 one. It's the same. And do it in such a way that you always leave the remaining all together in one big block so we can utilize them better in the future. You know, you can give them little branches here and there, but that's not a great technique. So I'm going to have a quick, just simple thing, /24. So /24 has numbers from 0 to 256, 255. And then if we go to the next level, and that's /25, we have 2, it's from 0 to 128, and 255. And the next one is /26. So this is 256 addresses, 128 addresses, 64 addresses, 32, and 16. So this one is 40. We'll start with the. Okay, anybody need to help there? Okay, this is the quick sheet that the blocks that I use. I just made it quickly. So we have /24 of 256. We can have 256 addresses. We can split it into 2 /25, so that's 128 addresses. Or 426, it goes into 64, 32. So every time you split it, you double the number of networks, but the slash increases. So the bigger the slash. Now, we have 90, 32, 40, and 2. So we start with the largest, 90. Okay, what's the next? What's the size network we can allocate for 90? 128. So yeah, so that's /24. Oh, 128, that's /25. So the first network B is going to be here. Right. Now the next one. So all this, the first half is all gone, our addresses. Now the next address is going to start 128. Well, that's gone. So the next one is 40. What? Yeah, slash 20? 26, yeah, which has 64 addresses. So this is slash, or network A, which has 64 addresses. This is slash B, we gave it 128. The next one? Slash C. So slash 27 is 32 addresses. Shall we give it to slash 27? No, we can. Okay, maybe I've gone a little bit maybe crazy now with the numbers. Can I reduce it? Can I reduce this to 20? Slash A to 20. Okay, now back again to you. 20. We go slash 27. So network A goes there. And we are allocating 32 addresses, right? Now yours, the next network, which is 32. Oh, 32 is another, yeah, okay. Oh, 32 should have been, hold on. That's B, we allocated it. Now C is bigger. We should have allocated C before A. I'll leave C to you. C is
32, so slash 26.
Slash 26, why? 64 addresses. Yeah?
32, yeah, you can't do any return.
Because see guys, they need 32 addresses, 32 computers. We might be able to give it slash 27, but slash 27 does not allow 32 computers, only 30 computers. Total address is 32, but minus the first and the last. So this would only allow 30 computers. So if you want 32 computers, then you have to go for the next larger one, which is the 64 size one. So this is where class C should go. And instead of 32, it's going to have 64 computers. Okay, you get the point? Yeah. The next one? Slash A. Where would you place A then? Slash 7. Yeah, in the slash 27, right? So A, and we're going to give it 32, even though it only needs 20. And then finally, slash 30. So because this one's 16 is split into 18 slash 27, slash 28, 29, 30. So that goes into from slash 16 to slash 8 to 4. No, hold on, there's something wrong. 36, 16. There we go. 30 is 4, right?
Yeah.
Then 29 should be 8. Then 28 should be 16. No problem, I'm skipping way too much. To 26.
Oh, you have 26 twice.
Oh, yeah, 27. So this should be 28, yeah. And this is 29, 30. Okay. Right, so slash 30 is the one that has 4. Yeah, that's fine. Okay, and somewhere here, 4 for the network. 4 network. Here's the last one, D. Now, everybody give me one starting address, the identifying address for one network, your network A, network B, network C. What's the identifying address? What's the broadcast address? What size the network, and what mask it is. So, what network are you doing? Slash A? Yeah. So where's the identifying address for A? It's the first available address. That. So that's 128. Half 128 is 64. This one, yeah. So that's 64, and that's number 32. And keeps going like that.
So 191.
It's 10. Dot 7. Dot 3. This is network subnetting. Dot. What? Oh, so that's 192, is it? Slash, yeah, that's 192 plus 64. 2 slash 27. 26. Oh, I'm sorry, 27. Yeah, okay. Right. /B, who's on /B? Yep, network B.
So that occurs at 10.3.0.
And what's the broadcast address?
10.127.
Sorry. What did we say /B? And it starts at 0, so 127 should be here. Okay, /C, where does it start at? Not 28 /26. Right? No, see, we're giving it here. We're giving it only 64 addresses, even though it needs 40, or C is what? Where's C? It's A, B, and C. Here's C needs 32 addresses, but we gave it 64. So it starts at 128 plus 164 plus 64. That means it's 191. Yeah? Or yeah. So that should be up to 191. And that's /26. Right, what's the broadcast address for network A? Just whatever network A is.
223?
Because it goes to whatever this address is. Yeah. 224, yeah. Okay, you can have a go at it. The idea is simple, so you need to practice a couple of exercises and you should be all right. Okay, guys, we'll leave it at this. Thank you very much. Good night. And